lesson, we're going to be talking about equivalent fractions and common denominators, and we're going to use the idea of equivalent fractions to help us be able to find common denominators. So first of all, what are equivalent fractions? Well, an idea, a way for me to think about it, is I'm going to think of 2 pies, 2 pizzas, 2 cakes, whatever we want to think of, and I could cut one of them into 4 pieces, and I could cut the other one into 8 pieces. And so now, did I change the size of either one? No, they're both the same size. So I could, if I wanted to, I could shade in 1/4 of this pizza over here, and on this side I'm going to shade in 1/4 over here. But since it's cut into 8 pieces, I'm not going to call this 4th, I'm going to call these 8ths, and I shaded in 2 of the 8 pieces. Here I shaded in 1 of the 4 pieces. We know that if we simplify 2/8, it'll become 1/4. So equivalent fractions are 2 fractions that can be simplified down to the same fraction. The same amount of the pizza is covered, it's just another name for 1/4 because we have our cake or our pizza cut into more than 4 pieces. So that's what equivalent fractions are. So we're just going to use the idea of paper folding to help us figure out equivalent fractions, how to find equivalent fractions. Now, obviously you can't see me folding a piece of paper, so I just have it underneath this box over here. I have what your paper would look like. But what we're going to start with is we're going to take a piece of paper, a strip of paper, and fold it into 4 equal pieces and shade in 3 of the 4 pieces. So here I have 3 of 4 pieces shaded in. Now I'm going to take that again, and I'm going to open it up. I'm going to refold it, this time into 8 equal pieces. And it's going to look something like this time. So now, how many pieces are shaded this time? 1, 2, 3, 4, 5, 6 out of the 8. Is more of the paper covered? No, because we didn't shade any more in. But because our pieces are smaller, we folded into more pieces. Now there's more total pieces that are shaded. So we can use this idea to help us write an equivalent fraction. So 3/4, having 3 of 4 pieces shaded in, is the same as how many pieces out of the 8 pieces we have here? Well, we counted it up, we said 6. So 3/4 is the same as 6/8. We didn't shade in any more pieces. We didn't change the size. We changed the sizes of the boxes, but we didn't change the size of the piece of paper. So 6/8 and 3/4 are the same. So now, how did we get from 3 to 6? How did we get from 4 to 8? Well, here we folded into 4 pieces. Here we folded it into 8 pieces. So we doubled, or times by 2, how many times we folded it. And 4 times 2 is 8. 3 times 2 is 6. That'll help when we get down to exactly how we find equivalent fractions. We're going to try one more with this paper folding idea. So this time we're going to fold a piece of paper into 3 equal pieces and shade in 1 of the 3 pieces. Have it open back up again, and this time we're going to fold the paper into 9 equal pieces. And we're going to look at now how many pieces are shaded. Well, so 1, 2, 3 out of the 9. As we can see, 3 out of these 9 pieces is the same amount as 1 out of our 3. So these 2 pieces right here, this 1 piece and these 3 pieces, are equivalent. It's the same amount shaded. We just took our paper and split it up into more pieces. So we can write these 2 paper strips as equivalent fractions. 1 out of the 3 pieces shaded is the same as how many pieces shaded out of the 9? Well, we said 3. So again, how do we get from 3 to 9, from 1 to 3? Well, here it was folded into 3 pieces. Here it was folded into 9 pieces. We tripled this time, or times by 3, how many times we folded the paper. We tripled it, so 1 times 3 is 3, 3 times 3 is 9. That's what we're doing when we're finding equivalent fractions. So now, how do we find equivalent fractions? That's what we're just doing. We are finding a factor that you can multiply or divide the completed fraction by equals a new fraction. So for example, in this one, we're going, how many times does 5 go into 20? Or we can list the factors of 20, which would be 1 and 20, 2 and 10, 4 goes with 5. Okay, well here we have 5, so 5 times what gives us 20? 5 times 4 will give us 20 over here. And we know that whatever we do to the bottom, we're going to be doing the same thing to the top. So 1 times 4 is 4. So 1/5 is the same as 4/20. We can try to couple them here so we can practice writing equivalent fractions. Here we have 2/3, and we want to know how many ninths that is. All right, well, how many times does 3 go into 9? 3 times 3 is 9, and whatever we do down here to the bottom, we're going to do to the top. So 2 times 3 is 6. So 2/3 equals 6 ninths. Ooh, looking at this one, how many times does 16 go into 4? That's backwards. So this time, instead of multiplying, we're going to have to divide. 16 divided by what number will give us 4? Or if you'd like to work with multiplying more, we can think of 4 times what is 16. We know that it's 4. So we'll have to be dividing by 4. So 16 divided by 4 is 4. 12 divided by 4 is 3. Now you may be wondering, well, how do I know if I'm going to be multiplying? Or how do I know if I'm going to be dividing? You need to look at the fraction that we're starting with and the fraction that we're ending up with. If the fraction that we're starting with, the number that we're starting with, is bigger than the number we're ending up with, we're going to divide because our answer is getting smaller. If we divide, our number will get smaller. If the number we're starting with, here 3, is smaller than what we're ending up with, then we're going to have to multiply because if we multiply, our number will get bigger. So always keep that in mind of if you're multiplying or dividing, look at the number you're starting with. Is it bigger or smaller than what you're ending up with? If it's bigger than what you're going to end up with, you need to divide. If it's smaller, then you're going to have to multiply. So let's try this next one. Here we have the numerator. We're looking for the denominator. And I'm going from 1 to 6. Our number is getting bigger, so that means we're going to be multiplying. 1 times what is 6? Well, 1 times 6 is 6. And whatever we do to the top, we're going to do to the bottom. So 2 times 6 is 12. And we can try one more over here. Again, we have the numerator. We're looking for the denominator. And we're starting with 4, and we're going to 24. Our number is getting bigger, so we're going to have to multiply again. 4 times what will give us 24? 6. 4 times 6 is 24. Whatever we do to the bottom, or whatever we do to the top, we're going to do to the bottom. So here we have 6 times 6 is 36. So to find equivalent fractions, we're always going to be looking at what number are we going to multiply or divide by to get from our completed fractions to the other one that we're trying to create. So now what we're going to do is we're going to take this idea of equivalent fractions to help us find common denominators. So first of all, when do we use common denominators? Why do we use common denominators? Well, whenever we want to add or subtract fractions, we're going to need common denominators. And that'll be covered in our next lesson. But for today, we're just going to work on finding common denominators so that we can use it for adding and subtracting fractions. So here's what we're going to do. We're going to use some fraction circles this time. And again, just like when we were doing paper folding, you don't have it in front of you, so we'll just use our pictures up here to help us. So we're going to find a 1/4 piece. So if I was using my fraction circles, that would be one like that. And a 1/6 piece, which would be one that looks like this. And what we want to figure out is we want a common color, just like a common denominator, for pieces that can cover both of these pieces exactly. Now, you might not be sure because you don't have the fraction circles in front of you, but I know that I can split each of these up equally into 12 pieces, and it'll be covered with the 12 pieces. And I know that I can do the same thing here, cut these each into 2, which will give us 12 pieces. So the 1/12 piece will cover 1/4 of a piece and 1/6 of a piece evenly. And there won't be any left hanging off on either one of these. And so now if I look at my picture up here, how many pieces did it take to cover 1/4? 1, 2, 3 pieces. So now we're going to write this as an equivalent fraction, just like we did before. 1/4 equals how many? Well, now we have 12 pieces. And how many of those 12 are shaded? 3 of the 12. Or if we didn't have a picture, 4 times 3 is 12. 1 times 3 is 12. Now we're going to do the same thing with our 1/6 piece over here. Here it took 2 pieces to cover 1/6 exactly. So we're going to write this one as an equivalent fraction. 1/6 equals how much? Again, we have 12 pieces, and of those 12, 2 are shaded. Or if I didn't have my pictures, 6 times what is 12? 6 times 2 is 12. Whatever we do to the bottom, we're going to do to the top. So we'll times by 2. So now we can figure out, we've determined what our common denominator is between 1/4 and 1/6. It's 12. So now we have 3 twelfths and 2 twelfths. Now we'd be able to add or subtract those together. Let's try another one using our fraction circles. This time we're going to use a 1/2 piece. So that would be this one up here. Here's our half. And we're going to use a 1/5 piece. That would be like this one over here. And again, we're just going to try to find a common color or common fraction piece that will cover up a half exactly and will cover up a fifth exactly. And if I'm laying this down and doing some experimenting, I know that the 1/10 piece will cover the 1/2 piece and the 1/5 piece evenly without any extras. So over here, if I'm using the 1/10 pieces, I'm going to end up with 10 total pieces. So now I have 10 pieces. Over here, I need to end up with 10 pieces as well. So we're going to have 5 down here. Oh, that line's not going to work very well for us. We're going to have 1, 2, 3, 4, 5. I know this isn't quite exactly right, but we'll get the idea down. And there we have 10. So now, I'm going to color this in again. There you go. I'm going to start with our 1/2 piece. How many pieces, or how many tenths fit on that 1/2? 1, 2, 3, 4, 5. 5 pieces covered it exactly. So we can write this as an equivalent fraction. 1/2 equals how many tenths? Because we said that the tenths cover both of them equally, or exactly. Well, we said 5 of those 10 are shaded. Or if we didn't have our picture, we could times by 5 times by 5. Now we're going to do the same thing over here with our 1/5 piece. How many tenths did it take to cover up a fifth? 2 pieces. So out of those 10, 2 of the 10 were covered. Or if we didn't have our pictures, 5 times 2 is 10. 1 times 2 is 10. So our common denominator between 1/2 and 1/5 is 10. And we created our new equivalent fractions for 1/2 and 1/5 with 5 tenths and 2 tenths. Now we'd be able to add or subtract those together. Now, just like we were doing with all of our other things, we want to be able to do all this without having to draw out a picture. So here's what we can do if we don't want to have to draw out a picture. To find common denominators, we need to find a common multiple of the 2 denominators. So first of all, a multiple. A multiple, when I think of it, is like counting by that number. Counting by 4s, counting by 5s. Until we find a number that they both share in common. So for 4, that would be like 4, 8, 12, 16, 20, 24, 28, and I could keep going on from there. 5 would be like 5, 10, 15, 20, 25, 30, and I would keep going on from there. When we're looking for multiples, multiples are always bigger than the number that we started with, because what we're trying to do is find what kind of pieces will fit into both a fourth and a fifth. And they're obviously going to be smaller pieces, and these would be smaller pieces because they're our denominator. Now as I'm looking through my list, I am trying to find a number that is in both of these lists. And we want the first one that we see. So the very first one I see right here is 20. So 20 is our common denominator. Now that we know what our common denominator is, we can create equivalent fractions, with 20 being our common denominator. This means that we could cut up a piece cut into 4 and a piece cut into 5, we could split them into 20 pieces and we'd end up having the same amount of each pizza covered. So now we're going to do just like we did before, to go from 4 to 20. How do I go from 4 to 20? 4 times what is 20? Times by 5, times by 5, and I'll get 15. Then I can do the same thing over here. 5 times what is 20? Times by 4, times by 4, and 4 times 4 is 16. So now we found our common denominators. We have our two new equivalent fractions, so we didn't change anything. They're still the same fraction, just not in simplest form. Now we'd be able to add or subtract. We're going to try a few more, another one here, to make sure we have this idea down. So 2/7 and 1/3, I want to be able to add or subtract them, so I need to find a common denominator. So first I'm going to find a common multiple for those two denominators, 7 and 3. So if I'm counting by 7s, that would be like 7, 14, 21, 28, 35, and going on from there. Counting by 3s would be like 3, 6, 9, 12, 15, 18, 21, 24, and so on from there. So now our common multiple is the first number that we see in both of these lists. And as I'm going through, the first number I see that they both have is 21. So that is going to be our common denominator. So 21 is our new common denominator. Now we need to find our new numerators by making equivalent fractions. So to go from 7 to 21, 7 times 3 is 21. 2 times 3 is 6. So 2/7 equals 6/21. And to go from 3 to 21, 3 times 7 is 21. And 1 times 7 is 7. So our common denominator was 21, and our new equivalent fractions are 6/21 and 7/21. We have a few more here. We're just going to try one last one just to make sure that we have this idea down. So we need common denominators for 3/5 and 2/3. So first I'm going to find those common multiples. And if you can figure out what these are without listing all the multiples, great. You don't have to do that, but if you're not sure, it's a great way to just write it all out. So here we have 5, 10, 15, 20, 25, and so on. Counting by 3s would be like 3, 6, 9, 12, 15, 18, and going up from there. The first multiple that I see that they both have is 15, so 15 is going to be our common denominator. So I'm just going to rewrite them down here. This one's going to go as 3/5. This one's going to go as 2/3. So to go from 5 to 15, I'm going to times by 3, and whatever I do to the bottom, I'm going to do to the top. So 3 times 3 is 9. Here I'm going from 3 to 15, so I'm going to times by 5, because 3 times 5 is 15. Times by 5 is on the top, and 2 times 5 is 10. So in this case, our common denominator was 15, and here's our two new equivalent fractions so that we'd be able to add or subtract them together. So in this whole lesson, we covered a lot. We covered equivalent fractions, we covered common denominators, but we needed that idea of equivalent fractions to help us find common denominators. And so, to find common denominators, you need to list multiples of each of the denominators, find the first one they have in common, use that as your new denominator, and then create equivalent fractions. And then from here, you'll be able to add or subtract with those fractions.